They called it the future of marine power. A revolution. The most advanced engine ever bolted to a transom, but within months, pistons were exploding through engine blocks. Fuel was leaking onto red-hot exhaust manifolds. And the U.S. Coast Guard was forced to issue an emergency warning: serious danger of fire and explosion, serious injury or death. That engine? It destroyed an entire company, bankrupted a century-old American legend. But here's the terrifying part. It's not even the most dangerous outboard on this list. Some of these motors poisoned families with an invisible, odorless killer. Others failed so violently, shrapnel flew into the cockpit. And one flaw is so common, so deadly, it claims more than 30 lives every single year. And you've probably never heard of it. Before you ever turn another ignition key, you need to know what's really hiding under that cowling. Now here's my question for you. Have you ever owned an outboard that left you stranded, scared, or worse? Drop your story in the comments. It might just save someone's life. Hit subscribe and ring that bell, because what we're about to reveal could be the difference between a perfect day on the water and a disaster you never saw coming. The story of outboard motors begins with a young Norwegian immigrant named Ole Evinrude, working in a small Milwaukee machine shop at the turn of the 20th century. In 1907, he built something that would change boating forever: the first commercially viable outboard motor. It weighed 62 pounds and produced just 1.5 horsepower. But it worked, and it sparked an industry that would grow into a multi-billion-dollar empire. By the 1930s, Evinrude's company had merged with Johnson Motors to form the Outboard Marine Corporation, OMC. For the next 4 decades, OMC dominated the water. Their engines powered everything from family fishing boats to military craft during World War II. In 1967, at the peak of their influence, OMC reported fiscal year sales of $233 million. They controlled 1/3 of all outboard sales on the planet. Johnson and Evinrude weren't just brand names, they were institutions. But dominance breeds complacency, and complacency in an industry built on engineering precision breeds disaster. The 1980s and 1990s brought what industry veterans call the horsepower wars. Mercury Marine, headquartered in Fond du Lac, Wisconsin, challenged OMC's supremacy with aggressive innovation. Yamaha arrived from Japan with 4-stroke technology that ran cleaner and quieter. Suddenly, manufacturers weren't just competing on power. They were racing against environmental regulations that threatened to outlaw their core products. The Environmental Protection Agency had been watching the marine industry with growing concern. 2-stroke outboards were dumping unburned fuel directly into the water. As much as 30% of every gallon simply washed through the engine and into lakes, rivers, and oceans. The EPA demanded change. Manufacturers had to find new technologies or face extinction. This is where the industry split into 2 camps. Mercury bet on Optimax, a direct injection 2-stroke system that promised cleaner emissions while preserving the lightweight, high-power characteristics boaters loved. Yamaha pushed 4-stroke technology, accepting heavier engines in exchange for proven reliability. And OMC? They partnered with a German company called Phi-Chi-AT to develop their own direct injection system. Each manufacturer believed they had found the future, but only some would survive to see it. The technology race accelerated through the 2000s and 2010s. Horsepower figures climbed relentlessly. 150, 200, 250, 300. Engines that once topped out at 40 miles per hour now pushed center consoles past 60. And in 2021, Mercury unveiled something the industry had never seen. The Verado V12. 600 horsepower from a single outboard, a 7.6-liter engine with electric steering integrated inside the cowling. Price tag: more than $85,000 per unit. Luxury boat builders lined up for allocation. Marine magazines declared it the most advanced outboard ever created. The Verado V12 represented everything the industry had been building toward for a century: raw power, technological sophistication, and premium pricing that would have seemed unimaginable to Ole Evinrude in his Milwaukee workshop. But behind every engineering marvel lies a margin for error. And when engineers push limits, when corporations rush products to market, when economics override caution, nature has a way of pushing back. The 15 outboards you're about to discover weren't built by amateurs. They came from legendary companies with century-long reputations. They passed inspections. They received certifications. They were sold to customers who trusted brand names their fathers and grandfathers had trusted. And they failed. Sometimes quietly. Sometimes catastrophically. Sometimes fatally. This is the story of what happens when the promise of power meets the reality of physics, economics, and human error. Number 15 on our list begins with a name that still makes marine mechanics shake their heads. The Evinrude Ficht. In the late 1990s, Outboard Marine Corporation was desperate. The EPA was tightening emissions standards. Competitors were gaining ground. OMC needed a technological breakthrough to survive. They found it, or thought they found it, in a German direct injection system called Ficht. On paper, the technology was elegant. Instead of dumping fuel through the cylinder like traditional two-strokes, Ficht injected precise amounts directly into the combustion chamber. Cleaner, more efficient, revolutionary. The reality was a nightmare. When the 1999 and 2000 model Ficht engines hit the water, problems emerged almost immediately. The motors smoked excessively. They knocked and pinged under load. But those were minor annoyances compared to what came next. Pistons and connecting rods began erupting explosively from engine blocks. Fuel leaked from injector systems onto hot exhaust components. Between July 1999 and December 2000, OMC received what the Coast Guard later described as an unacceptably high number of reports of fires and explosions. The Coast Guard issued an emergency advisory with language rarely seen in marine bulletins. Serious danger of fire or explosion with continued use that could result in serious injury or death. By December 2000, OMC filed for bankruptcy. A company that had dominated boating for 7 decades, that had built engines for the U.S. military, that had powered generations of American family memories, was finished. Bombardier acquired the remains and eventually discontinued the Evinrude brand entirely in 2020. But the Ficht wasn't the only ticking time bomb from this era. Number 14. The Mercury Optimax, specifically the 2000 through 2004 models. Mercury's answer to emissions regulations was their own direct injection two-stroke system. The Optimax used a unique two-stage process. Fuel mixed with a burst of compressed air for better atomization. The engines ran cleaner than carbureted two-strokes and delivered impressive whole-shot acceleration. The problem was the air compressor. These compressors were mounted on the front of the powerhead, spinning at engine speed, building the pressure necessary for fuel injection. And they had a disturbing tendency to fail without warning. When a compressor let go, the damage cascaded through the entire powerhead. Pistons scored, cylinders gouged, engines that cost thousands of dollars became scrap metal in seconds. Marine mechanics began calling the early Optimax engines time bombs. One forum post captured the sentiment perfectly. Most customers call the older models time bombs because they can blow up any time. The failures were so widespread that Mercury faced a class action lawsuit. The company settled by extending warranties, 3 additional months for 2000 models, 6 months for 2001, a full extra year for 2002, but for owners who'd already experienced catastrophic failures, those extensions meant nothing. Experienced mechanics learned to replace Optimax compressors preventively at around 500 hours, before they could fail and destroy the entire engine. But most recreational boaters never knew this. They trusted the Mercury name. They assumed their engines were safe. Number 13 brings us to Mercury's flagship 4-stroke line, the first-generation Verado. Launched in 2004 and 2005, the Verado was Mercury's premium offering, supercharged, whisper-quiet, and marketed as the future of outboard technology. It was everything the Optimax wasn't: smooth, refined, and expensive. But the early Verados harbored their own secrets. The bell crank assembly, the mechanism that transferred your shift lever commands to the engine's transmission, had a tendency to seize. When it stuck, you lost all control over gear selection. Forward, neutral, reverse. The engine decided, not you. Imagine approaching a crowded marina and discovering your throttle is locked in gear. The Verado's drive shaft seals created another hazard. These seals sat where the drive shaft passed through the oil pan. And when they leaked, which they did with troubling regularity, oil slowly drained during operation. Owners wouldn't notice until warning lights flashed, or worse, until the engine seized miles from shore. Mercury addressed these issues in 2008 with a redesigned system, but thousands of first-generation Verados had already been sold. Number 12 on our list isn't a single engine model, it's something far more insidious, an invisible threat that has claimed dozens of lives and poisoned hundreds more. Carbon monoxide. Every gasoline outboard produces this colorless, odorless gas as a byproduct of combustion. In open water with good airflow, it disperses harmlessly. But in certain conditions, at idle, at slow speeds, with the wind at your back, carbon monoxide accumulates in deadly concentrations around the stern of your boat. The National Institute for Occupational Safety and Health conducted studies that should terrify every boater. They measured carbon monoxide levels at boat swim platforms and found concentrations reaching 42,600 parts per million. For context, NIOSH considers 1,200 parts per million immediately dangerous to life and health. Some boats were producing more than 35 times the lethal threshold, just inches from where families swam and played. Two-stroke outboards were particularly deadly. Their incomplete combustion generated far more carbon monoxide than four-strokes. And a popular activity called teak surfing, where riders held onto the swim platform and surfed the boat's wake, put participants directly in the exhaust plume. At least 11 people died from teak surfing. 10 more suffered serious poisoning. The victims felt dizzy, confused, nauseous. Most assumed it was seasickness or too much sun. By the time they realized something was seriously wrong, they were losing consciousness. Between 1990 and 2004, authorities documented 571 boating-related carbon monoxide poisonings. 113 of those people died. And the Coast Guard believes the actual numbers are far higher. Many CO deaths were simply recorded as drownings because no one thought to test for poisoning. Number 11 takes us to a brand synonymous with Japanese precision: Suzuki. Their 2005 through 2008 DF90 through DF200 models suffered from a flaw so subtle that most owners never suspected it until their engines were destroyed. Inside these outboards, where exhaust gases passed through internal channels, Suzuki engineers had installed an oxygen sensor with a carbon steel plug. That plug sat in an aluminum housing. And when two dissimilar metals meet in the presence of salt water and electricity, a process called galvanic corrosion begins eating one of them alive. The aluminum housing corroded from the inside out. Owners who flushed religiously, who followed every maintenance schedule, who did everything right, they still found their engines seized and ruined. Repair bills ran $2,000 to $2,500. And Suzuki's response? No recall, no warranty assistance. Customers who trusted the brand were left holding the bill. One devastated owner posted online, 5 years and only 350 hours of use later, our sweet Suzuki succumbed to the much-discussed internal exhaust passage corrosion. The saddest part? No recall, no efforts to make good. Number 10 comes from the brand many consider the gold standard of outboard reliability: Yamaha. The 2005 through 2007 DF150 and DF200 four-strokes contained an internal balancer shaft designed to reduce vibration. When functioning properly, it made these engines remarkably smooth. when it failed, and it did fail, the consequences were catastrophic. A failing balancer didn't just rattle loose, it destroyed the oil pump. Without oil pressure, the powerhead starved and seized. Total engine loss. The cruel mathematics of Yamaha's balancer failure worked like this. If you caught the problem early, before complete failure, the repair cost around $1,000. If you didn't, $15,000 or more for a new powerhead. Most owners had no idea the problem existed until their engines were already destroyed. One buyer shared his experience. At a touch over 1,000 hours, a balancer let loose in one of the motors, destroyed the oil pump, which led to powerhead failure, a common problem on these motors from the 2005 to 2007 era. The most infuriating part? Yamaha offered no widespread recall. The company that built its reputation on bulletproof engineering left customers stranded with five-figure repair bills for a defect they couldn't have predicted or prevented. Number 9 sounds like something from an industrial accident report: the Suzuki flywheel fracture. In 2004, Suzuki's DF200, DF225, and DF250 outboards were manufactured with flywheels cast from incorrect metallic composition. A flywheel isn't a small component. It's a heavy rotating mass at the heart of your engine, spinning at thousands of revolutions per minute. When improperly cast metal reaches those speeds and suddenly fractures, physics takes over. Shrapnel explodes outward with tremendous force. The Coast Guard recall stated the danger plainly. Flywheel could break, injuring operator and passengers. 1,012 motors carried this defect. Number 8 returns us to Evinrude, this time after Bombardier had acquired the brand. The 2001, 2004, and 2005 direct injection models, ranging from 100 to 250 horsepower, suffered from fuel injector fasteners that loosened or broke during normal operation. When fuel leaks onto hot engine components, you get fire. When fuel accumulates in enclosed spaces, you get explosion. Nearly 6,000 motors were recalled, but the pattern was becoming clear. Direct injection technology, rushed to market to meet emissions deadlines, was proving far more dangerous than anyone had anticipated. Number 7 brings us to the present day, and Mercury's flagship V12 Verado, the $85,000 marvel we discussed earlier. In August 2023, Mercury issued a voluntary recall affecting both the 600 horsepower V12 Verado and the 500 horsepower V12 C Pro. The culprit was a steering position sensor that could fail and force the engine into Guardian mode, reducing power output and, critically, reducing steering capability. Remember, the V12's revolutionary feature was electric steering integrated inside the cowling. When that system malfunctioned, you didn't just lose convenience, you lost control of where your boat was pointing. Owners flooded forums with complaints. One wrote, "We've had some major issues with our 4600s, steering sensors, steering housing seals, and oil leaks. Mercury techs have been on our boat more times than I can count." Number 6. Mercury's V8 and V6 four-stroke models from 2018 and 2019 suffered from water intrusion into the shift actuator. Saltwater seeped in, corroded internal wiring, and eventually caused complete shift failure. Service Bulletin 2019-01 warned that affected engines could enter Guardian-forced idle, lose shift control entirely, or refuse to restart. Number 5 involves Honda, a brand many consider the most reliable nameplate in any engine category. Their 2021 through 2025 BF115, BF140, BF150, BF250, and BF350 models contained shift actuator link rods that could break during normal operation. The Health Canada recall notice was blunt. Consumers should immediately stop using the recalled Honda outboard engine. But then came the devastating follow-up. Unfortunately, service parts are currently unavailable due to supply chain constraints. Honda told owners to stop using their engines they couldn't repair because parts didn't exist. Number 4 isn't a specific model. It's a phenomenon so deadly it has earned its own name: the circle of death. When an operator is ejected from a moving boat, knocked overboard by a wave, thrown by a sudden turn, or simply losing balance, something terrifying happens if the engine keeps running. Steering torque from the rotating propeller slams the motor hard to one side. The boat swerves violently, often ejecting anyone else aboard. Then the unmanned vessel begins circling at speed, returning again and again to the spot where its victims are treading water. The propeller comes around, and around, and around. This is the circle of death. It has killed people in seconds, inflicting wounds so catastrophic that survival becomes nearly impossible. And it remains one of the most preventable dangers in all of boating. Number 3 on our list is the propeller strike itself, not limited to any single outboard, but endemic to every engine ever manufactured. The Coast Guard documents more than 30 propeller-related deaths annually. The fatality rate for propeller injuries runs between 15 and 17%. The amputation rate is nearly identical, and these numbers are believed to be underreported by as much as 90% because many incidents are never officially logged. The mathematics of a spinning propeller are merciless. At 3,000 RPM, a 3-blade propeller delivers 150 strikes per second. The blades create parallel, deep lacerations that sever muscle, tendon, and bone with surgical efficiency. Head and torso strikes are almost always fatal. Number 2, the universal danger of any outboard operated without a kill switch lanyard. Federal law now requires kill switches on recreational boats under 26 feet and mandates their use when operating on plane. But as one safety expert observed, few boat operators bother to actually use kill switch lanyards. In 2017, at Lake Gage, Indiana, 10 people were ejected from a single boat that entered the circle of death. A conservation officer had to jump from a moving personal watercraft onto the unmanned vessel to stop it. In 2022 off Massachusetts, a 24-foot boat circled for an extended period while rescuers scrambled to reach 2 men in the water. Officials warned the boat had enough fuel to continue for 4 more hours. Number 1. The most dangerous outboard ever built isn't a specific model at all. It's any outboard mounted on a boat whose operator doesn't know its history, doesn't understand its weaknesses, and doesn't respect its power. So why do these failures keep happening? Why do legendary companies with century-long reputations produce engines that explode, corrode, seize, and kill? 3 forces collide beneath the surface of every dangerous outboard. First, the innovation trap. Manufacturers racing to meet emissions deadlines or beat competitors to market-release first-generation technology before it's truly proven. The Fetch disaster, the early Optimax failures, the V12 steering issues, all share this DNA. Second, the regulatory gap. The Coast Guard relies heavily on voluntary compliance. Injury reporting is inconsistent. State laws vary wildly. The true scope of outboard-related accidents remains hidden behind underreporting that may mask 90% of actual incidents. Third, the corporate calculus. Recalls are expensive. Warranty extensions are cheaper than engineering fixes. And brand loyalty often protects companies from consequences that would devastate other industries. But knowledge is protection. Before purchasing any outboard, research its recall history. Ask whether it's a first-generation design. Verify dealer service capability in your area. Always wear your kill switch lanyard. It's federal law for a reason. Install a marine carbon monoxide detector. Never swim near an idling boat. And never, ever assume that a famous brand name guarantees safety. The water doesn't forgive carelessness, neither do spinning propeller blades. The most dangerous outboard is the one you don't understand. Be the owner who does.